We've finished for now with ridge regression. Let's move on. If you remember, when we were deciding how to penalize the loss function, we had various choices. The main thing we needed to do was to make sure that large values of the coefficients created a penalty. Ridge regression was the sum of the squares of the coefficients, which is essentially the L2 norm. But how about the L1 norm? If you remember that, the L1 norm is simply the sum of the absolute values of all the coefficients. Because this is the L1 norm, this is also known as L1 regression or L1 penalization. But Hastie and Tibshirani, who popularized this, also call it the LASSO. LASSO, which they claim stands for least absolute shrinkage and selection operator. I can't even write that all. Shrinkage and selection operator. To be honest, I'm not sure if they're having a laugh, but they do use the words shrinkage and selection. The idea of shrinkage is we take massive coefficients and we force them to become smaller in some kind of way which controls complexity and therefore controls the variance that we were talking about before. So shrinkage is certainly true. But what about variable selection? Well, in ridge regression, which we had before, as you increase the value of lambda, the coefficients get smaller and smaller, but they tend not to drop out completely. Whereas when you use L1 penalization, as lambda gets larger, the coefficients of features which are not so important for the model get set to 0, which means that those features just get excluded from the model completely, and you're therefore kind of chucking away features which aren't important to your model. You're doing variable selection, hence selection. That's really all we need to say about the LASSO for now, or L1 regression, L1 penalization. We're going to head straight over onto Python and look at this with, first of all, the polynomial regression example, and then with Amy's house pricing. Here goes.